And once again, thank you for joining us for our continued coverage of TIA 2013. Joining us at the TI Now desk is one of our keynote speakers, Dr. Chih-Lin I. She's the chief scientist at China Mobile and the head of the Green Communication Research Center at China Mobile Research Institute. And Dr. I, welcome to the program.
Thank you, Abe.
Did I pronounce your name correctly?
Perfect.
Okay, I gave it a shot. Thank you very much. I want to talk about the massive network over at China Mobile. Energy efficiency must be paramount to you. What is your current energy consumption?
Well, absolutely. As the world's largest mobile operator now, as you know, we have 1.1 million base stations, primarily 2G and 3G currently, with 200,000 4G base stations to come by the end of this year, and then 350,000 base stations by the end of next year. The scale and its associated power consumption is, of course, of paramount importance. As of last year, our power consumption was 14 billion kilowatt hour, okay? And as we expect the upcoming massive deployment of 4G network, as well as the widely recognized, anticipated exponential growth of the traffic on the network, we really need to pay greater attention to the energy efficiency, given the fact that currently 40% of our Opex is the electricity bill.
Dr. I, what measures are you taking right now to improve energy efficiency at China Mobile?
Well, we have been taking multifaceted approaches. Actually, China Mobile headquarters had launched a Green Action Plan as of 5 years ago, and including taking care of both the equipment grading of its energy efficiency in the procurement process is a key parameter, as well as recycling, reuse the packaging material. But more importantly, in our network operation, we pick the most energy efficient components, such as multi-carrier broadband power amplifier, and using energy tracking technology. In addition, on the base station level, we try to take advantage of the tidal effect of the actual traffic, which is not homogeneous, neither in time nor in space, like you know. So we can selectively, dynamically turn on and off maybe different base stations, maybe different carriers, maybe different equipment resource as the traffic varies. There are more technologies we are planning to use, but so far we have gotten 52% energy efficiency improvement measured by the power consumption per unit traffic, okay? So just to give you an idea, the 14 billion kilowatt hour power consumption last year would have been 30 billion kilowatt hour had we not started this Green Action Plan 5 years ago.
Dr. I, let's talk about C-RAN for a moment. First of all, can you just give us a quick overview of what C-RAN is and what benefits, I guess, fundamental benefits does the C-RAN bring to the industry?
Okay, it's one of my favorite topics because I view C-RAN as a revolutionary evolution path of our industry. Actually, our industry must take, which means that traditionally in the mobile network, first of all, we know that the radio access network, which is composed of all of base stations, consumes about 70% of the total power consumption of our system. So that's where we need to really improve its power efficiency. Now, traditionally, each base station is kind of self-contained in terms of coverage, in terms of control, in terms of mobility management, and all the resources allocation. But as you probably know, about more than 10 years ago, we went into what's called distributed base station, which means you take the radio unit out of the base station housing and put it next to the antenna. That helps you to improve about 50% of the transmission power. But you kept the digital processing and the intelligence still on site of each base station. In C-RAN, instead, we are pooling all the things we left in that base station housing out of the base station site and take it to a centralized location where we would maybe pull in tens, dozens, or maybe even 100 base stations, digital unit, all together make a pool there. Then in that way, we first of all eliminated the housing that was originally needed. There we immediately removed all the power consumption that was associated with air conditioning, with environmental control, which used to account for about half of the base station power consumption. Okay? And once you centralize all of the baseband unit, made a pool, you could conveniently exercise the multi-point collaboration of multiple sites, which is an essential function in especially 4G network to gain the interference management benefit and the capacity improvement from there. Okay. One step further, once you put all of the BBU in one housing, you actually don't need to just stack them up. You can consider actually realizing this pool using general purpose servers, meaning that you can actually take advantage of the cloud computing platform advantage. So you realize your base station as virtual machines, and maybe with a little bit of accelerator with really computational intensive functions, but by and large you can think of a base station as a soft base station and build upon the cloud platform. So you can benefit from all of the advantage that the virtual machine in the cloud computing center would bring. I think that's the future. So C-RAN, the C stands for first step centralization, second step collaborative processing, third step, final step, cloud platform.
Dr. I want to get to 5G before we run out of time. Energy efficiency, will it be a key consideration in 5G?
Oh, for sure, absolutely. I think, as we all know, in our industry, from 1G to 2G to 3G to 4G, all along, the most important design parameter was the spectral efficiency. That means bit per second per hertz, because you want to boost up capacity, you want to make use of the limited spectrum. For 5G, that will still be true, but spectral efficiency will no longer be the only important factor. Energy efficiency, bit per second per watts, will be side by side together with bit per second per hertz. So we look at 5G, we think it will be the first generation of the wireless technology where we really start doing co-design of spectral efficiency with energy efficiency. And I think it's a must. The future has to be with energy efficiency in mind in any new system, new standards. And I would like to say that the future has to be green. If it's not green, it doesn't belong to the future.
An interesting way to finish the segment. I know Dr. Yi, you're an important addition to TIA 2013. We all appreciate that you made the trip in. And I know you had a keynote address. Hopefully that went well. I heard it did.
Yes, actually I had participated in a series of activities today, and my keynote will take place tomorrow morning.
Yes. And for our audience, what time is that tomorrow?
I believe it's at 10:30.
Perfect.
Yeah.
All right. Well, again, we appreciate your time.
Thank you very much, Abe.
Thanks for being with us. And thank you for watching our continued coverage of TIA 2013, again here at the Gaylord National in Washington, D.C. As usual, for more information on how you can still attend, please log on to TIA2013.org, and to follow us on Twitter, please go to TIA_now. So long.